Alright, this is homework 3.7, implicit differentiation, and this is problem number 5. Problem number 5 tells us to find dr d theta for the expression theta to the 7/8 minus r to the 7/8 equals 1. And with implicit differentiation, how we start is by differentiating both sides with respect to the independent variable. And which one is the independent variable in this case, you might ask? And it's going to be theta. Theta is going to be the independent variable. And it's because we're looking for dr d theta. We're looking for the change of the dependent variable with respect to the independent variable, which tells us that r is nothing more than a function of theta. So r is a function of theta, and we're curious in how that function changes with respect to theta. So anyhow, we take d theta both sides. The derivative of any constant is 0. Right here we can use linearity and separate it into the derivative of this one minus the derivative of that one. The derivative of theta to the 7/8 using the power rule is 7/8 theta to the minus 1/8. And so the thing to remember is when we bring down the 7/8 to the front, like we did here, we have to subtract 1 from the power, because that's what the power rule requires. Well, 1 from 7/8, you could think of that as 7/8 minus 8/8, because 8/8 is 1. 7/8 minus 8/8 is negative 1/8. And similarly for r, we bring down the 7/8. 7/8 r to the minus 1/8, because we subtract 8/8 from 7/8, because we're subtracting 1 from the power. And you may think that's it, but not quite. Remember that r is in fact a function of theta, and so we took the derivative of the outer function when we did the power rule. Now we have to take the derivative of the inner function r, which is a function of theta. So we will multiply this by dr d theta equals 0 because of a constant over here. So now we just need to solve for dr d theta. You'll notice here that we have 2 7/8. What that means is that I can multiply both sides by 8/7, and if I were to distribute this into each term, they would in fact cancel, and this just goes to 0. So what we're left with is theta to the minus 1/8 minus r to the minus 1/8 equals 0. Now we can add r to the minus 1/8 over to the 0 side, and we'll end up with theta minus 1. Oh, and I'm sorry. There's a dr d theta tied to this term. Dr d theta equals 0. Now we'll add this term over there. So that gives us theta to the minus 1/8 equals r to the 1/8 times dr d theta. Now we've got dr d theta where we want it, so we'll divide over by r to the minus 1/8. I'm sorry, when I added the r to the minus 1/8 over, it still remains minus 1/8. So when we, actually, if we wanted to write this out in a way without negative powers, we could write this as 1 over theta to the 1/8 equals 1 over r to the 1/8 dr d theta, because these are negative powers, so we could write them in the denominator as positive powers. And then to find dr d theta alone, we'll multiply both sides by r to the 1/8 times r to the 1/8, and these cancel as intended, and what we're left with is finding what dr d theta is. Dr d theta is equal to r to the 1/8 over theta to the 1/8. And remember, the power rule always applies for any sort of fractional powers. You'll just need to subtract 1 from the power once you bring it down to the front. And always be sure to figure out what your dependent and independent variables are. This isn't in terms of x and y, but what they ask for is dr d theta, so you'll find out that r is the dependent variable, theta is the independent variable, and that will help you take your derivative. I hope this was helpful, and I'll see you next time.